I'm back. Let's do a lead code. First day where you have been in all the rooms. Okay, so I did this question before, just now, and it is quite tricky, but it's a very nice, neat DP question. Sorry for spoiling. Okay, so let's go through. There are n rooms you need to visit, labeled 0 to n-1. Each day is labeled starting from 0. You go in and visit one room a day. Okay. Initially on day 0, you visit room 0. The order you visit the rooms for the coming days is determined by the rules in a given 0 index array next visit of length n. Assuming that on a day you visit room I, if you have been in room I an odd number of times including the current visit, on the next day you'll visit a room with a lower equal room number specified by next visit I, where next visit I is between 0 and I. Okay, if you have been in a room I an even number of times, including the current visit, on the next day you'll visit room I plus 1 mod n. Return a label of the first day where you have been in all the rooms. It can be shown that such a day exists. Since the answer may be very large, return it modulo 10 power of 9 plus 7. Okay, so let's go through an example because that's kind of difficult to get a head around. Give these indexes. That's 1, 0, 1, 2, 3. So that's the index. This is the next room to visit. Notice how that the next room to visit is always less than the index. Next visit I is always between 0 and less than or equal to I. We want to figure out how many days it will take to reach all the rooms. Initially you start off at room 0 and that tells us the next room to visit. So let's actually keep track of the number of days it takes to reach a particular room. Min num days to reach room for the first odd time. So we've reached room 0 on the first day. And then what happens is this next room to visit tells us which room we actually visit next. And that's actually the exact same room that we were in before. Okay, so now that we're back in room 0, well, this time that we reach room 0 is going to be the second time we reach the room. It takes 2 days. 2 days is the min number of days. Min number of days to reach room for the first even time. Alright, then if we keep track of these two somehow, eventually we'll reach the last room, which is, say, here. Whenever a number goes at this position, because that's the first time we reach the last room. And we know that we've visited all the rooms when we reach the last room, because there's no way that we can actually progress to the next room unless we've visited the previous room twice. Why? Because all the room numbers, all the next room to visits numbers are less than the index. This means the number of days to reach the room of index 1 is going to be 1 plus this value here, which is 3. Now, okay, how many times does it take to reach? Okay, so what value goes in here? We're told to visit room 1 again, which is the same room. That will take 4 days. Okay, so all good so far. When does it get tricky? This example is actually not that great. Let's change it so that telling us to visit room 1. This is always going to be 5 because we've had to visit room 1 2 times to be able to progress to room 2. Now what value goes in here is, well, we take a look at what room next to visit. So this actually brings us back to room 1. From this starting position, how many days does it take to get back to room 2 so that we visit it an even number of times so that we can progress to the next room? If this said room 0, then I would be taken back to the very first room, and all I have to do is, I know that it will take 5 number of days to get back to the same position. So in this case, this will be 10 because it will be just 5 times 2. But if this was 1, then let's just pretend that first initially takes 10 days to get back to the same position, assuming that this value is 0. But then, since we started a little later in the rooms, so this is 1 instead of 0, so we subtract the number of days it takes to get to room 1, which is, well, if you think of it like prefix sums, we subtract the 2 days off from 5. So that's 5 minus 2 is 3, and then you add 3 to 5. So this should be 8. And then this one will just be 8 plus 1, which is 9. So if I actually give this a test, this should give, the answer here should be 8. Alright, because the days are actually 0 indexed. So this is the 9th day, but actually the 8th, 0th indexed day. What was the answer? Return 8. Yep. Yeah, so that's basically how it goes. It's like this is the DP arrays that we need to create, and that's the rule we have to follow. So let's create the DP arrays. Okay, one thing we have to watch out for is this is all very big numbers. The constraints n is up to 10 to the power 5, and so we want to work with longs because the answer could be very large, and we should take it modulo 10 to the power 9 plus 7. So let's do, let's type def long. Say mod is equal to 1e9 plus 7. Each element we have a vector size 2. Let's just initialize everything to 0. Go through each of the elements, and we just follow the way we did it here. First off, we probably want to start here and have a base case. We always know that first DP values here are 1 and 2. So we can say dp0 of 0, dp0 of 1 is equal to 2. Then here I could say dpi at 0 is going to be equal to I minus 1 at 1 plus 1. But that could potentially go overboard. 1e9 plus 7, so let's take that modulus. Now, dpi2 is a little bit more tricky. It's what this value here was times 2, like we did here before. I did 5 times 2 is 10, and then we subtract the number of days it took to get to the next room we have to visit. 0. So let's just do times 2. Then we minus. Well, we can minus this value here, 2, when we see a 1 is the next room to visit. So next room to visit is 1, which is this. When we subtract this value, so actually let's just go and look here, and we just do subtract 3 minus 1. That way you don't have to look at the boundaries and have an if condition. So let's do instead subtract dp visit at I 0, and then we subtract 1. Yeah, but we can actually expand this out, and you could just expand the brackets out and just do this, and then modulus this. So what do we return? We return dp at the last value, which is next visit dot size minus 1 at position 0. But we have to subtract 1. Problem with this is this value modulus could be 0. So if do 0 minus 1 and then modulus again, that will give us something negative, which is not what we want. So we have to add mod. Okay, let's give that a go. The modulus thing is a pain in the ass. So yeah, nice. Hopefully that makes sense. If that did, give it a thumbs up, and I'll see you in the next video.